Hey guys, welcome back to another video. So here we'll be looking at the second part of question 6, and here we'll be tackling A and B. So let's look at A. So using the identity for tan A plus minus B, show that tan 3 theta minus 45 degrees can be proven to look like that hand side. Okay, so we just first need to know what the expression for tan A plus minus B looks like. So I've did it over here. And well, this is actually tan A minus B. For the plus version, it's just the inverted sign. So it'll be plus here and minus here if we chose tan A plus B. Now, to make this look really easy, just look at both these equations. You can see that, they look almost identical. The only difference here is that tan B seems to be 1. In other words, the B value representing 45 degrees seems to have a result of 1. So here we can just replace tan 45, and in the calculator this gives us 1. Remember, make sure it's in degree mode. That means this tan 45 is also 1. And replacing A with 3 theta, well, you're going to get the exact same expression. So it'll just be 1 plus tan 3 theta times 1. And that's it. That's literally proven. Okay, now let's look at the next bit. Okay, part B. Now, first things first, every time you see the word hence, always bring in the previous result. So that's why I copied it here, and always think about it for a moment. Now, looking at the question, it wants us to solve for a given angle, or at least a given range, the following equation. Now, when you look at this first time, you might think, okay, doesn't quite look familiar to the previous, but actually it does. If you rearrange this carefully by dividing 1 plus tan 3 theta across to make it look like this on the right hand side, you can see that this equation here is identical to the right hand side over here. Okay, now what that tells us is that you can immediately, and with thanks to the word hence, replace this entire equation with the tan 3 theta minus 45. So that's why I got it over here. So all of this can be replaced by this equation over here. Now here, this is where the confusion might begin, or it might not. You notice that they both got tan, so probably, instinctively, you'd probably just cancel both the tans, which is actually okay. You do get a mark for that, but it won't give you the rest of solutions. What you have to think about is that what if you actually tan inverse to both sides? That is, suppose we tan inverse the right side. We did theta plus 28 equals, well, tan inverse of the tan 3 theta minus 45. And actually, it goes both ways. I should have done it here as well. You're tan inversing both sides. Now, as weird as this look, what actually happens here is that both sides cancel out, so all the tans disappear. So you're actually left with the theta plus 28 and the 3 theta minus 45. Now, thanks to the properties of tan, and this is actually some of the results. You could actually firstly just solve theta here straight away, and doing that would give us let's see, just subtracting 2 theta across, minusing 28, and then dividing by minus 2, you'll get theta equals 36.5 degrees, and that of course fits through the range. Now you have to be very careful because you could miss a whole solution. So remember, imagine this was just a regular question. If you tan inverse a problem, then you would most likely get a plus or minus 180. So think of this, plus minus 180 degrees. This is what happens when you tan inverse. But then you might also get negative solution because you tan inverse both sides. So that's why I wrote plus minus 180. So then when you solve this one for plus, when you stick into this equation and solve it with the plus 180 or minus 180, you'll end up with minus 53.5 degrees, which is out of the range, or 126.5 degrees, which is